Okay, let's start. Let me share my screen. Am I audible?
Yes, sir.
Okay. Screen is visible. Okay. Then in the last class, we are discussing about DFA, that is deterministic finite automata. Today, we'll continue with the same topic. The basically DFA is comprises of 5 individual tuples, and each tuple carries some information, and based on this information, we can generate some diagrams. Okay, and these diagrams are supposed to validate a string which is comprises of some input symbol. Okay, now in your screen a particular DFA is highlighted. Graph of a DFA, that means when we are going to draw a DFA, this kind of graph we have to draw based on the DFA criteria of DFA, criteria of the language, criteria uh, of the input symbol, okay, strings. The representation of graph may be different, but in all DFA you have to draw some circles, you have to use some arrow, okay, to distinguish, to highlight what that thing is and how it going to work. Okay, and as I told you, there is a transition function in within the 5 tuple which highlights what is your present state. Like suppose this one transition function which indicates what is your current state, what is the input symbol, and what output you will get. For example, we can elaborate using this. This is your A is your present state. You insert 1 as the input symbol, then you will reach B. Okay, that means in transition function we are highlighting that there is a present state and there is a input symbol. If we run the transition function with the help of these two entities, you will get a next state. For suppose transition function, I'm writing in the chat box, but we cannot write the symbol, that's why I'm use the transition function name itself. Suppose my present state is A, then my input symbol is 1. I will get this kind of. Suppose my transition function, everyone see the set box. Transition function, that means you have to write the symbol here. Then This is my current state, this is my input symbol, then what will be the B is my next state. Okay, then for represent the scenario or to represent the theoretical explanation of a transition function graphically, we need a transition graph. Okay, that means suppose the word file is visible to everyone.
No, sir.
No, let me share it again then. Wait. Class আছে কৈছো এক second. Now is it visible?
Yes, sir.
Okay. Now, whatever we have draw right in the set box, right? This is a theoretical suppose explanation. That means this is the transition function. Okay. These are the present state. These are the this is the input symbol. Then we will get the output. Now, how you can draw a transition graph then? Because we have to show the same thing using diagram. So what we can do, we can use some shape. Suppose what kind of shape we are using, there are different shape. Okay, we are using circle, we are using circle to represent a state. This is a circle. Okay, then this is arrow. That means from this point, suppose we are adding text. Okay, a, okay, a, this is one input symbol. Then again B. Do you getting something? Suppose insert then symbol. Let me more symbol. Forget about it. Okay, are you listening? Now, am I audible or not?
Yes, sir, you are.
Okay. Now, in your screen, there are two type of circles. Okay. In one, there's only one circle in the state of A, and in the state of B, there are two circles, and within two circles, I am writing the state. That means when we have to highlight a final state, always remember when we have to highlight a final state, that means we have to draw two circles. Final state. Okay, and for other than final state, all states are uh, highlighted under a single circle. That's why whenever we are writing, we are drawing a DFD, no need to highlight this circle as a end state. No need to highlight like this. Okay. But you have to highlight the initial state as a start state using this arrow. That means this is the transition function which execute the result that there is a initial state or present state A where I am giving a input A. Okay, after performing this operation it will reach B, and B is the final state because from B you cannot move anywhere. You can suppose, let me see whether this kind of arrow is available or not. No. Yes, but like here, that means if you want to travel from B to A, you can, oh sorry, B to B, you can move. Okay, and for this you need again two input symbols. Again, suppose input symbol like this, 0. Okay, that means again we can write it as a transition function from B using 0, you can reach B. Okay, similarly in case of A also, in case of A also, if you want to move from A using your input symbol 0, you will reach A again. Okay. Here you can add comma 1 because there are two input symbol. That means these are some transition functions we are executing, where the in first transition function the present state is A, the A is also in the initial state for this particular DFD. Okay, in present state is A, then we give a input symbol 1, then what will be the next state? Next state is B. That means from this A using 1 we can reach B. Similarly, if we want to move from A using input symbol 0, you can move, you can do a circular move. That means you are starting from A and you will reach A again. Similarly, from B, since it is a N state, you can come back to A again, but again you have to go to B. But in this particular DFD, it will be like, if we start your journey from B using input symbol either 0 or either A, you will reach B itself. Then what will be the strings it will generate, or what kind of strings it can it will accept? From A, if you start your journey from A using 0, A 0 1, 0 comma 1, 1 is this one, 0 1. Again suppose one string this one, then comma, then suppose you continue your rotation here 2 to 3 times, suppose 0 comma 0 comma 0, 3 times you are continue the iteration from A. You start the journey from A, again reach A, again start the journey from A, reach A, again start the journey from A, reach A, 3 times 0, then 1, we reach the destination D. That means to complete, always remember, to complete a DFA, you must have to reach the final state. If you continue here from A using 0, from A using 0, it will goes to an infinite loop. Okay, it will go to an infinite loop and your DFD is not complete. That means whenever you have to complete your DFA or later in NFA also, always remember one thing, that always remember one thing, that you can repeat the iteration, you can repeat the iteration as many times as you want. Suppose from A using 0, you can repeat it 100 times, 1000 times, but to complete this string you can continue 0 0 0 0 0 0, you can continue these things up to n times, but to complete the string you have to take 1 as an input symbol and have to reach B. Until you reach B, your DFD is not complete. Okay, that means at the end you have to reach your end state. So similarly, suppose again you will take another string, suppose 0, then you take a 0 1 iteration here, then directly shifted to 1 to B, then in B also you can continue your iteration. Suppose 0 1 time you have do the iteration, then you are using 1 as an input symbol and reach B. This is also another string. That means these strings, this kind of string will accepted by this above DFA. Okay, suppose let me say, suppose I have a string called 1 1 1 0 0 1 0. Let me check whether the string is acceptable by this DFA or not. That means from start to end, from initial state to end state, we have to move. And when we move, if it go through this particular input symbol, and at the end, when it comes to 0, if we reach the final state, or we are may retain in the final state, you may reach the final state in the second iteration itself. But in the final state itself, if you are able to do this iteration and able to retain the final state, in the final state, it means your this particular string is acceptable by the DFA. So let us check. Suppose from same string from A, you are using 1. Yes, we can move from A to present state to next state using a 1 input symbol. Yes, we are reaching B. Okay, then again 1 is using 1, we can move to anywhere because we are reaching final state. Yes, in the final state also you are using you have a input symbol 1, it is highlighted. So from using 1 we can take a circular iteration. Then again 1, again we can take the same type of iteration. Then again 0 0 double 0, 0 first 0 second 0, then again 1, yes 1, then again 0. So that means when we reach the 0, we will retain in the final state. That means this string is acceptable by this particular DFA. Okay, now suppose we have another kind of DFA. Let's show you. One, and we are, that means in final state B, if we get an input symbol 1, it will back to A, and using again 1 as the input symbol in the initial state or at the current state, it can again move to B. Okay, now let's check whether this particular string is acceptable or not. Okay, 1, yes, from here we can reach B. Then again 1, yes, we have a input symbol 1, from B we are reaching A. Then next one, yes, again we are reaching B, final state. Now 0, yes, we can take a self loop, again 0, we are taking a self loop here. Then again 1, yes, we are reaching A again. Now 0, yes, I can take a self iteration within A itself, but because it is the last digit, last input symbol. But after taking this last iteration, do we reach the final state? No, we are still in A, and A is not the final state. B is the final state, because that means for this particular DFA, this string is not acceptable. Okay, do you get my point? Are you getting or not? Okay, good. Now if I change the string to 1, suppose, okay, then in last one, yes, from A we have a input symbol 1 and we are reaching B. That means for this particular DFA, this string is acceptable. That means what we are going to validate, we have some strings, we have to draw some input symbols, oh sorry, some DFA, and we have to validate. And for this, we have to use this kind of graph. This kind of graph is known as a transition graph, where that means the graph which indicates the transition from one state to another with the help of some input symbol and transition function. It is known as a transition graph. Is it clear to everyone what is transition graph? Okay, now write one point. Everyone write in your notebook the transition graph. Now one point you have to write is a very important. Okay, I have already mentioned that when a string is said, like suppose this is a string, na? When a string is said as a acceptable by a DFA, when it reaches the final state at the end, अगर वो फाइनल स्टेट नहीं पहुंचता, जैसे हम लोगों ने डिस्कस किया है, अगर if this string not able to reach the final state at the end, this string is not acceptable by the DFA. To write one point as a note, right? That a string is said to be accepted a string is said to be accepted by the given FA. FA means finite automata. A string is said to be accepted by given finite automata only when it is processed by transition function. It is processed by transition function. Write the symbol in such a manner that in such a manner that it ends at the final state. It ends at the final state. That means this string should be end at the final state. Otherwise, this string is not acceptable. Okay. Because for different kind of strings, we have to draw some DFS, or from the DFS we have to extract different kind of strings. So we have to know what kind of string is going to accept by the DFA, or from a DFA what kind of accepted string we can extract. Okay, now write transition graph. Right, a transition graph is a collection of three things. A transition graph is a collection of three things. Number one, a finite set of states. That means a finite set of states. That means if there is no state, suppose there is nothing like A and B, can we draw anything like this? if we don't have a state like A or B or C or D or M and O, okay, if we don't have any state, okay, can we draw something like that? Obviously not. Suppose if we don't have money, can we buy something? That means if you want to buy something, what is the primary aspects do you need? It is money, obviously, or anything using which you can buy something. Basically, for buying something, we are using money, any kind of money. Suppose wallet money, reward money, cash money, any money. That means you need money, currency. Exact word is currency. That means we need currency, any form of currency in rupees, dollar, pound. Okay, but that means we need currency. If we don't have currency with us, we cannot buy something. So similarly, if you don't have any state in this particular DFA, we cannot create a DFA, or we cannot draw the transition graph. At least one, because we can say that using one single state also we can draw a DFA, and in that case, uh, for initial state and final state is the same state. That means if we uh, suppose ignore this left portion, suppose from A or something like that, if there's only one state B, then what we can say that B is the start state and B is the final state. Ignore this portion, this one. That means at least one state we need to draw a transition graph, and the single state we can highlight. That means we need the start state, and we can say that the start state itself is the end state. Okay, then next point, an alphabet an alphabet of possible input letters of possible input letters of possible input letters from which input strings are formed. From which input strings are formed. That means, I'm repeating the line, an alphabet of possible input letters from which input strings are formed. That means, if we don't have the input symbols like zeros and ones, can we move from A to B? Suppose we have a state A, we have a state B. Suppose there is a river. In both sides of the river, there are roads. If there is no bridge there or no connectivity like ferry or speedboat, anything, can we move from one side of the river to the another one? Obviously not. Either we need a bridge, either we need a ferry, either we need a machine boat, or now anything, any kind of elements we must require from travel one side of the river to the other one. So similarly, if we don't have any kind of input symbol, okay, we cannot run the transition function. And if we are not able to run the transition function, we are not getting the next state. That means we are idle in state A because we don't know what to do. And when we create a string, when we extract a string, what we are writing? We are writing simply input symbols. That means using this DFA or using this graph, we can extract this string. That means in string we are simply highlighted what are the input symbol we are processing just now. That means input symbol is very much essential to draw a transition graph. Then the next one, third point is a finite set of transition a finite set of transitions That's so how to go how to go from some states to some other. A finite set of transitions that show how to go from some states to some others. Based on reading specific substrings of input letters. ঠিক আছে? Okay, that means these are the 3 points we must require while we are drawing the transition graph. I'm sharing a screenshot of a portion from the book so that you can go through it in your WhatsApp group. Okay, the same thing we are discussing. That means while we are drawing the DFA, basically we are drawing some transition graph. That means from this state we are moving to the another one, then moving to the another one. We can move within the same state. Okay, and at the end we are reaching the final state, and once we reach the final state we can say that the transition is complete, or the string we are creating throughout our journey, the string is accepted by the particular DFA. I am sharing a screenshot in your WhatsApp group. Okay, this is something about transition graph. Okay, that and the next thing we must know about the transition table. That means now we are discussing about transition graph. Next thing we are discussing about transition table. Once we are familiar with transition graph as well as transition table, we are ready to draw the DFS. That means what are the important things we need to know apart from the tuples. Apart from the tuples, 5 tuples, what are the important things we must know before drawing the DFA is one is called transition diagram. I think all of you are very much clear about the transition diagram. That means the diagrammatical represent of the states and the input symbols, and from which state they are moving to which one. And transition table, the same thing we are going to draw theoretically in tabular form. That means right now we are highlighting these things using a diagrammatical point of view. The same thing we are going to highlight using the tabular form. This is called transition table. Once we are familiar with the transition table, the next we can go for the drawing of DFS. Okay, in the next class I'm going to discuss about the transition table. Okay, any query from anyone? The meeting will end in 5 minutes. Okay, if you have any query, you can share your query in the WhatsApp group, and everyone, still till today only 10 participants have joined. So make sure, okay, it's not only the CR responsibility. Share your classmates to join the class. Okay, if they are not attending the class, they are considered as absent, and at the end they are not able to sit in the exam. And the next important thing is if they are not joining the class, how they are able to understand the topics. Today only 10 participants have joined out of suppose 16 and 17. So make sure everyone join. Okay, and go through the notes in ERP, search in Google, and try to make you understand about the topics we have discussed. And if you have any query, you can ask me in a WhatsApp group or in the next class. Okay, is it clear to everyone?
Okay, sir.
Okay, go through the topics. Okay, go through the topics. Today only 10 participants. The attendance percentage is not good. We need 100% attendance. So make sure that everyone join. Yes, Sasanka, you are saying something.
Sir, 10টা মান আছে।
আজি আজি 10 জনে জয়েন কৰিছে কিন্তু আমাৰ টোটেল ষ্টুডেন্ট 17 নহয় জানো?
স্যার।
বাকি কিটা কিয় জয়েন কৰা নাই? সদায় একেকিটা সদায়তো একেটাই কোৱা সবকে জয়েন কৰা, সদায় একেকিটাই ষ্টুডেন্টে জয়েন কৰি আছে, ক্লাছ এটেন্ড কৰি আছে। ঠিক আছে?
মানে সেইকেইটা কৰাই নাই আগৰ পৰাই ক্লাছ।
জয়েন কৰিবলৈ ক'বা। ঠিক আছে everyone, go through the topics we have discussed today, and if you have any query you can ask me in a WhatsApp group or in the next class. Okay, thank you everyone.